So let's see how to do this recursively. Well, it relies off the fact that basically, how was I generating these higher factorial numbers? I was going like, okay, so 4 factorial was 24. What is 5 factorial? Well, 5 factorial is 5 times 4 factorial, right? I can rewrite 5 factorial over here as 5 factorial is equal to 5 times 4 factorial, right? Because these numbers up here are all 5 times, basically all we're doing is tacking on 5, and all these numbers over here, they're 4 factorial. It's 4 times 3 times 2 times 1. That's what 4 factorial is. 4 times 3 times 2 times 1. That's all that is. But actually, that's even more. That's 4 times 3 factorial. Right? That's 4 times 3 factorial. 3 times 2 times 1, that can be written as 3 factorial. And 3 factorial, therefore, is, right, that's 3 times 2 factorial. 2 factorial is 2 times 1 factorial, and 1 factorial is just itself. It's 1, right? So that's what we call a base case. Basically, something that's really easy for us to solve. 0 factorial is 1, 1 factorial is 1. Those are super easy. It's what we call a base case. And the idea behind recursion is that we're a bit lazy in solving our things, so we're going to just basically try to reduce everything. If it's not a base case, then it's too hard for us to solve. So we'll just try to reduce the problem and make it simpler, right? Oh, calculating 5 factorial, that's so hard. Well, what's 4 factorial? Because I know that 5 factorial is whatever 5 factorial, I know that 5 factorial is whatever 5 times 4 factorial is, right? Calculating 5 factorial is hard. 5 times 4 factorial, that's a bit easier. Well, what's 4 factorial? Oh, well, that's 4 times 3 factorial, a bit easier, and so on and so forth, right? N factorial is equal to, if we were to express this mathematically, we'd say that n factorial is equal to one of two things, right? It would be equal to 1 if n is 1 or 0, right? Or it's equal to n times n minus 1 factorial if, and let's go ahead and line these up a bit better. If, right? N factorial is 1 if n is 1 or 0. N times n minus 1 factorial otherwise, right? 0 factorial, 1 factorial, they return 1. But otherwise, right, a number like 3 factorial, that's 3 times 2 factorial. That's 3 times 2 factorial, 2 times 1. And likewise, 5 factorial is 5 times 4 factorial, or 5 times 4 times 3 times 2 times 1. So how can we put that in code? Well, the amazing thing about these programming languages is that they can we can add these new commands. Public void, let's just go ahead and write a foo here, right? And there's nothing that stops you from writing a command, and I'm just going to do something that's really stupid here for a second. There's nothing from writing a command that's like this, public stack void, system.out println foo, right? Nothing's stopping me from writing a function that does this, a function that calls itself, right? Nothing stops me from doing that. Now, the only thing we have to do is be careful about how we use it, right? If I call foo over here, it's going to obviously be an infinite loop. Or is it? So I printed out a bunch of foos, and then it crashed and burned with a lot of errors. I'm actually having a hard time. You'll actually have a hard time finding the actual error here, but it's not going to be an infinite loop, as you might suspect. You get a error. Oh, and it says it's a stack overflow error, right? That's an interesting error that we'll have to look up. Well, we know what a stack is, right? We know what a stack is now. So a stack overflow error, you might understand what it kind of means is that we overflowed the stack. Well, what stack? We never made one. Well, we'll get to that in a bit. But the idea here, the important idea here, is that if I'm clever about it, I can write a method that calls itself. And I can do it in such a way that I'm not going to crash my program. So let's go ahead and write this factorial function using this recursive definition. So I'm going to call this one just fact for short. Public static long. I'm going to call the recursive version fact instead, so we can have both of them on the same page. And it's also going to calculate the n factorial, right? So the first thing we want to do we have basically two things we need to do when we create a recursive function. It's very easy. You only have to do like two things. The first thing is that you want to figure out what your base case is. The thing that's super simple, right? What's the answer where you can just spit it out instantly without having to do any calculation? And that in our case is, what if n is equal to 0 or n is equal to 1, right? If n is equal to 0 or 1, we are just going to go ahead and say return 1, right? That's because 0 factorial is 1, n factorial is 1. We are done. Else. Otherwise, we need to return something else. Otherwise, what are we going to return? We are going to return n times n minus 1 factorial. Okay? So I'm going to return n times n minus 1 factorial. Well, I can't just do n minus 1 factorial over here, right? But I do have a function over here. Return n times n minus 1 factorial. And actually, if I go out of my recursive, so if I go out of my distraction-free mode, we notice that I get a little indicator over here that's saying that, whoops, over here, saying that this is a recursive call, right? My program recognizes that such. So, don't really need to see that though, right? So this is it. This is it. This is a working program, believe it or not. So let's go ahead and test this over here. System.out.println, instead of factorial, we're going to do fact, which is our non-recursive version. Which is our recursive version. So now fact 5 gives us 120. Fact of 2 is equal to 10. Sorry, fact of 2 is equal to 2. Fact of 10 is equal to, I don't know why I said 10 there. It was really weird. Maybe because I was hitting F10 to run this. Factorial of 10 is equal to 3,628,800. Factorial of 20 is equal to that ridiculously big number. Okay. So surprisingly this works, right? If I pass in 1 or 0, I suppose I should do that now. Pass in 0. You get 1. Although I should mention that passing in a negative number, this won't work at all, right? You'll get an infinite loop if you've got a negative number. See if you can figure out why later on. So how does this work? How does this actually, work? Because it seems like magic, right? It seems way too easy in terms of the length of code compared to what we had earlier. I'm going to move it down here. Now, what happens here, and in the next video, I'm going to go into this in a bit more detail. I'm going to go over this again and draw it on the board for us. But what's going on here? Well, what I did is I passed in 5. If I pass in 5 over here to the fact function, it's going to go, okay, I'm going to return 5 times whatever fact 5 minus 1 is. So 4 factorial. I'm going to return 5 times 4 factorial. Okay, but then your computer goes and calculates 4 factorial. It passes 4 into itself, and it says, is 4 0? No. Is it 1? No. Okay, so we're going to return 4 times 3 factorial. Then it's going to go, and then 3 is going to return 3 times 2 factorial. 2 is going to return 2 times 1 factorial. And 1 is going to return that and pass the stuff all the way back up. And we're going to see that in the upcoming video after that. But that's the way. This is a recursive function. This is your first recursive function. Congratulations on writing it.